Hello everyone. Today we are going to be using what we practiced in class today and what we had in the video last night, which is isolating the variable. And we're going to use that to solve systems of linear equations with substitution. Make sure you put today's date, which is January 23rd, I think, 2014. And it is page number 7. Make sure you're putting your page numbers and your dates everywhere. A little warning for you. This lesson is tricky. There are a lot of things that you have to kind of put together. We have to remember distributive property, order of operations, isolating the variables, solving equations, SADMAP. I mean, there's a ton of stuff that's just kind of coming together here. Once you get the big picture and you practice it, you're going to be just fine. But this video might be a little overwhelming, and I don't want you to panic. Just try and figure it out the best you can, okay? We'll work on it tomorrow in class. So today we are going to solve systems of linear equations by isolating the variable in one equation and substituting it into the second equation. That's where the term substitution comes in. Let's look at the steps. The steps aren't going to make a lot of sense until we work through some practice examples, so bear with me. First, we need to solve the first equation for one of the variables. And honestly here, guys, I put first. It could also be the second equation. What you're really going to get in the habit of doing is whichever equation is easier to work with. That's what you're going to be isolating the variable for. And you'll see what I mean in just a minute. Next, you're going to substitute that equation into the second equation. I'll show you how to do that. You're going to simplify, and that's going to tell you the value of one of your variables. And then you're going to plug that number in, the one that you found out for one of those variables, into either equation to find the value of your second variable. Sorry, I didn't mean to make that line there. So when all is said and done, you're going to have two numbers, an x and a y, an ordered pair, that gives you the solution to the system of equations. And the reason we would do all of these steps is you can't always solve a system of equations by graphing. Perhaps you would end up with a point that has decimals or fractions as the solution. And it can get really complicated to try and figure out exactly whether it's 4 1/3 or 4 1/4, for example, for your value of x. So when you need a precise point of intersection, you want to use something like substitution. Also, when you're solving systems by graphing, it's real easy to accidentally make a line a little crooked or at just slightly the wrong angle. And so a little mistake like that can really cost you the question, can cost you the problem, because you won't get it right if your angle is wrong. So let's look at an example here. And as we work through this, remember, it's a little tough. Hang with me. You will figure it out. We have two equations here, negative 5x plus y equals negative 2. And negative 3x plus 6y equals negative 12. This is how you'll frequently see linear functions when you're solving a system. You'll see them written in standard form. You may remember standard form is when both variables are on the same side of the equal sign. If we look back at our steps, step 1 is to solve the first or the second equation for one of the variables. What I'm looking for here is which equation is easiest to get a variable alone. I'm going to be isolating a variable here. I'm going to choose this first equation because it has a y that's almost all by itself already. This y does not have a coefficient, so I don't have to worry about that. The only thing I need to get rid of is this negative 5x. I need that to move to the other side. In order to do that, I'm going to use simple algebra. In order to cancel negative 5x, I want to get rid of this whole term, so I have to get rid of the x too. I am going to add 5x. Those will cancel. And then over on this side, I have to add 5x again, leaving me y equals 5x plus negative 2. Okay, with me so far? Let me fix that negative sign. Now, the second step, substitute this new equation into your second equation, your other equation. Let's look at what that actually means. I am going to take this, 5x plus negative 2, and my solving here has told me that that is what y equals. Y is 5x plus negative 2. So I can take that and plug it in for y. Let me show you how you do that. You're going to leave the rest of the equation exactly the same. So I'm going to keep negative 3x. I'm going to keep my plus sign. I'm even going to keep my 6. But then instead of y, I need to put 5x plus negative 2. I have to be careful here because it's easy to make a mistake. Put parentheses in, okay? 6 times y, so it's going to be 6 times 5x plus negative 2. Remember how I said you were going to use distributive property? Here it is. And then equals negative 12. We have plugged it in. Now we are going to simplify to find the value of one of your variables. What you may notice when you do this is that it leaves you with just one kind of variable in the equation. All you have is x. So if we have one variable, we should be able to solve it and find out what that variable equals. I'm going to use distributive property, do 6 times 5x, that gives me 30x. 6 times negative 2, that gives me plus negative 12. I have my equal sign, negative 12, and then I've got this negative 3x plus over here on the side. I've gotten rid of my 6 because I distributed it here. Now, I need to combine some like terms. I have negative 3x plus 30x. Those are going to combine to give me 27x plus negative 12 equals negative 12. It's to the point now where I have just a basic two-step equation. I'm going to use SADMEP to tell me what order to do things in. I want to get rid of subtraction and addition, so I have this plus negative 12. You need to ask yourself, what is going to cancel a negative 12? And you need to add 12, a positive 12, to cancel that out. Plus 12 on both sides. You're left with 27x. Your negative 12 and positive 12 cancel. Negative 12 plus 12, what does that equal, guys? It equals 0. Remember from previous units, do not be afraid of the 0. The 0 is not your enemy. The 0 is perfectly fine. I have to continue solving this. I have to get x alone, so I divide by 27. Divide by 27, leaving me x equals 0 divided by 27. Don't be afraid of the 0. It gives you 0. So what I have done here is I have found out my value for x. I now know what the solution for this linear system of linear equations. I know my x value is going to be 0. Let's find out what I do next. Finally, I plug this number, the 0 that I just got for x, into either of your equations to find the value of the second variable. I'm going to take this 0, plug it in to either equation. It doesn't matter which one you choose. Let's choose the first one. I'm going to rewrite it down here so it's a little bit easier for us to see. Negative 5x plus y equals negative 2. I plug 0 in. I get negative 5 times 0 plus y equals negative 2. Remember, I don't know what my y is yet. That's what I'm trying to find out. Negative 5 times 0 is 0 plus y equals negative 2. And of course, 0 plus y is just y. So y equals negative 2. I have found both of my variables, so the ordered pair that should satisfy these equations is 0, negative 2. Of course, you're not done. These problems take a long time. What you need to do now is check. You have to do the checking step. I'm going to erase all of this stuff. You guys should leave it on your paper, obviously, because that's part of your notes. But I just want to make sure we have plenty of room to show all this, okay? So the point that I am saying is a solution is 0, negative 2. Remember, that's my x and my y. In order to check, I have to plug those into both equations. So I'll start with this first one. Negative 5 times x, which is 0, plus y, which is negative 2, should equal negative 2. Negative 5 times 0 is 0. 0 plus negative 2 should equal negative 2. Sorry that my equal signs are messing up, guys. It's my pen. And then 0 plus negative 2 is negative 2. And does that equal negative 2? It does. We're happy. Yay. But we're not done. We have to check the other one. Plug 0 and negative 2 in. I have negative 3 times x, which is 0, plus 6 times y, which is negative 2, equals negative 12. Negative 3 times 0 is 0. 6 times negative 2 is negative 12. Should equal negative 12. 0 plus negative 12 is negative 12. I've said that number a lot today. So that makes us happy. Both of our equations check, so we are happy we have solved the problem. I poorly estimated time. We aren't going to have time to do this example, but what I will do is I will show the answers so that if you'd like to try it on your own, you're more than welcome to before you try the reflection. So here are the answers to this system. And now that I have the answer up there, let's go ahead and show you the reflection. Remember, really take some time to try this on your own if you can. It's going to help prepare you for tomorrow. And your reflection question, please put your answer into Edmodo, is as shown. Make sure all of your work, including this checking step, is shown on your notes when you bring them into class tomorrow. All right, or Monday it will be. Thank you guys so much. Have a great night. I will see you Monday. Sorry I went over by a couple minutes. I apologize. Bye-bye.